tube station on the Metropolitan line. Been closed for years.
Oh, look, it's a map.
It's London. Subterranean London.
What's going on? Why are the doors open? Oh no.
Can someone tell me how the hell he got into our system?
Oh shit. He hacked us.
Some powerful words here. Not the shit part, but he hacked us. This is something that it's coming more often. And funny enough, everyone realized that what was hacked here? IoT devices. What type of devices? Doors. So at the moment, we have a very nice development. We are, by 2018, we're expecting 6.4 billion endpoints, IoT endpoints. So that means basically there is no human interaction behind that. By the end of 2020, it's going to be 20 billion endpoints. So funny enough, we've done a survey, and this is like overall of the world. You see here UK, DAC. And the funny part is those devices are the ones that are already in place. Okay, so you have from smart TVs, refrigerators, everything. You guys have them at home. You're using cameras on the network. That's what it is. So what's the impact of the whole thing? I mean, the survey says everything. There are IT, C-level IT guys that don't concern about that. They don't worry about that. Some of them are pretty confident that they can stop and protect themselves. But funny enough, if you look what type of security they have. So how can you actually stop something that you don't see? So first thing is visibility, obviously. Visibility is most important. I mean, we have here devices that are on the network doing something. You have no clue what they're doing. Communicating with somebody. You don't know why. You have to classify those devices first. And the classification usually is done with an agent. That's the traditional way. Those devices, they don't accept agents. Okay? You cannot install an agent on a camera or in a fridge, unless it's funny. So the other thing is, you know, how will those C-level guys, how they pretend to be secure? Okay, so some of them are just telling us, okay, we rely on standards. Great, Bluetooth, you know, Wi-Fi, those protocols are standards. But that's exactly the protocols that the hackers, the adversaries are using. The other one, like, oh, well, we don't care. Nothing will happen. Oh, we will develop a specialized agent for this. Good luck with that. And obviously, oh, we have a password. How easy is it to go around the password? Quite easy, I think. So if you look at this, this is at the moment what's out there. I think there are many companies developing IoT, or even the traditional word SCADA devices. Okay? And how can you get a grip of this? Installing everyone an agent? Probably not possible. How vulnerable is it? Oh, we saw already a couple of really good hacks around. And I mean, obviously, if you think about 20,000 billion unmanaged endpoints, what it means is that every company will have 66% possibility that it will be hacked. Okay? There will be a breach, and this is from IDC by the end of 2018. That means every second company? Nice. What it means is also that you will have less than 10% devices where you have a human interaction behind the device. Everything else is automatic. Those are the cameras. Those are the devices that are actually outside. Even printers, traditional printers, they're getting smart. That means they have some type of a operating system behind that. All right. HAVAC systems. Everybody saw probably, the Mr. Robot series. How they're hacking there? Oh, they're hacking HAVAC systems. How is it possible to hack an HAVAC system and then compromise a company? Well, if you stop HAVAC in a server room, it's going to be very hot very soon. And what's happening with the servers then? They probably stop working, destroying data. So you can actually harm everything. So the danger is everywhere. There are various scenarios that can circumvent security systems. Obviously, VoIP devices. I mean, snooping in a VoIP device, listening to phone calls, that's possible. We are in a very interesting time at the moment. One of the vulnerabilities that I would like to address, and there was a friend of mine, Sammy, and I'll show you a video in a minute. He was hacking a regular camera, security camera. And I'll show a couple of pictures later how I was hacking different other systems without any problems. So without any explanation here, let's listen to Sammy, who was he was one of the guys who actually discovered Mirai botnet. Everybody knows about that. Those are the cameras that got rogue and obviously attacked other systems, denial of service attacks. And you can see here, even we thought we stopped them. Today, 2017, there are over 1,750 tweets out there. So it's still ongoing.
Hi, I'm Sammy Kampgar. Today, we're looking at a common enterprise-grade, network-based security camera. IoT devices are softer targets and easily exploitable. Industry attention has mainly focused on IoT vulnerabilities in consumer products, when the reality is that IoT is already in the enterprise. An unsuspecting IoT threat, like this camera, can often be hacked in a matter of minutes. This camera took less than an hour because of a risky vulnerability, the default password, which is the same across all devices from the manufacturer. The attack itself can be automated in seconds. This is a common practice in many IoT devices. Once a hacker takes advantage of it and gains access to the device, he or she can move around and do anything as the root user, such as planting a permanent backdoor. IoT devices often have unrestricted or insecure management interfaces. When looking closer at this camera, we see it provides a web interface to anyone on the network using the default credentials. And these credentials are pretty much weak passwords that are easy to guess or maybe brute forced. As we browse, we clearly see the video stream, with options to alter the video and network, but upon closer interrogation of the device's ports, we find that it's actually running SSH, which is a secure shell. Now, when we attempt to connect to SSH on the device, we can log in with the default credentials, and are provided a Linux shell with root access on the device. Since many IoT devices run embedded Linux, having root SSH access makes attacks easy to script and automate. It gives hackers full privilege and allows them to control the device completely or use it as a proxy to hit other systems in that network or even other organizations on the internet. They can essentially SSH into that device and then bounce from there to any other IP address on the internet or any other machine on the local network. We can also plant an SSH authorized key. This is basically a key that allows us to SSH in the future at any time without having a password. This means that if the administrator actually changes the password at any time in the future, the attacker can still log in. That gives the attacker full access to the local network even after the administrator has changed the password. This is really interesting because to the administrator, nothing will appear out of place. We can also install a backdoor that makes an outbound connection or a reverse shell to a system we control outside the network. The attacker would have full control from a remote location to conduct all sorts of attacks, such as ARP and DNS spoofing or man-in-the-middle attacks, without any ports needing to be opened on the firewall. The real kicker to this attack? If an administrator ever decides to change the password to the device, the reverse shell is implanted in the file system and continues to run, and still provides the attacker with full access to the device. The attacker no longer has the new password. Even after the device is rebooted, the access will persist. Hackers can also use the same backdoor across many devices and join them together into a botnet, taking orders from a command and control server, essentially producing a massive distributed network that can be used for DDoS attacks. Here you can see I'm controlling devices and others simultaneously from my own command and control server. This would allow an attacker to launch any type of distributed attack. If the attacker isn't on the local network, but the administrator placed the device on the internet with a public IP, the device then exposes the entire internal network to the attacker as well.
Now, the attacker only needs to reach the device over the internet, and once SSH'd in, has full access to the internal network without ever having been on the network in the first place.
It's important to be aware of these threats. Always assume that these devices will be deployed with little security, scrutiny, or oversight, often with default passwords and misconfigured to expose essentially everything.
This was really nice. So how is it actually to hack? And Sammy is pretty good, and I've tried something else. So I just used basic tools to somehow gain access, for example, to a screen of a guy who was somewhere working. I was able to read emails in India. I don't know if you can see that. This is a purchasing department. Oh, that's a hotel. I could stay for free in a hotel. I could stay for free in a different hotel. I can actually exit an X-ray machine and take a look on a baby of a pregnant woman. And this was my biggest one. That's actually a factory. I can stop the factory. You can see here, shut down. It's easy. I push it button and that's it. So what I'm using is a probably well-known database, not even in the darknet. It's a regular database. And I use a different database that has various standard passwords. Because all those devices that I've accessed, they have still the standard password, the factory password. Who is actually changing a camera password if they deploy the camera? Not many people. How many devices are out there that are vulnerable? I would say more than 90%. That's funny. That's actually a smart home. If I would be a burglar, hey, I can access and I can open up the back door, disable the alarm, and I can walk in and take whatever I want. Oh, that's another one. This is actually a power plant here in Spain that is here freely on the internet. Nice. So, me working for Forescout, this company is the company that starts with C. We believe strongly that everything that you see, you can actually protect, okay? So it means whatever is out there, we will be able to provide you every IP addressable device. We will discover it, we will classify it, we will assess this device and provide you the information on a screen. How are we going to do this? Well, there are various points. Okay, we have multiple methods. One is we communicate with networking using standards. The second one is we passively receive SNMP traps from those network devices. The other thing is, again, using standards like .1x. Okay, we will monitor, if possible, monitor the HCP traffic. We don't care about the payload itself, but the header information is quite important for now. The other thing is if we have span, obviously we can monitor the traffic, run Nmap scans, use credentials to log on endpoints if they belong to a corporate device, corporation, and then scan those devices. We can utilize NetFlow. We can even import external sources in our database, monitor virtual machines, obviously, in the private or in the public cloud, classify devices by PoE. And the last one, obviously, yes, we do have an agent, but it's not necessary. With all this information, we will create a database, a conceptual database that we can use as a profile for a device, and then we decide automatically how this device and if this device is supposed to be on the network or not. You know, the information that we collect, this is a list that is not complete, but it's part of what we will collect from those 10 points that I've just mentioned. Okay, I will not go through this. It's basically information that is available on the network. We have policies that we can build. We have conditions for those policies, and we can run obviously also some actions on the network. The funny part is our security system is out of band. The network is never going through our systems, but we listen. Okay. I mentioned we can control them. Yes, we can run actions. We can notify, we can segment, we can block endpoints after we actually classified and clarified those devices. What we're doing is we're reducing the footprint of attack. And again, there is a list what we can do. We can notify, conform, and then restrict endpoints based on their profile, automatically out of the policies. We have also an orchestration section where we integrate with third-party vendors. I mentioned already that we can import information from already existing tools. So that's basically what it is. We work with, again, this is not a complete list, but those are the vendors that are basically the leaders in, in various quadrants. So we will import this. We use an open API called Control Fabric, nothing fancy. It's really a basic API. What will happen then is we integrate with all these security devices that usually act as islands. They don't talk to each other, but if they talk to us, we can correlate the data and we can create some specific actions based on the data that we're receiving. Come on. So how is it happening? If a device connects on the network, usually what happens is we pick it up immediately, right? When we pick it up, we can say what type of device it is. Then we can assess this device. So is it vulnerable to some kind of attacks or not? We will communicate with third-party vendors. If there is a SIM, we communicate to the SIM. A SIM is a great tool to analyze data. And then obviously if we get the information, yes, this device might be compromised, might be a possible attack, has an IOC, whatever is out there, we will run some actions on this device and we will either limit the access to the network, take it offline, or even start a process to make it healthy again. Well, the best practices at the moment that everyone should, but nobody is doing it, okay, use is dynamic network segmentation. Don't put IoT devices on the same network as your regular production network. Obviously, classify your IoT. Just don't install just for fun, right? Detect suspicious behavior. That's really important. I mean, obviously, a camera or a printer who starts scanning the network, maybe something is wrong with this one. Or an endpoint that's supposed to be a camera is suddenly a TV. I don't know if this is good. Unfortunately, my time is over as far as I know. No, I still have time because she's just run off. I'm happy to answer some questions. I'm still out there for a couple of, probably 1 hour. Going to be there, so if you have some questions, you're welcome to join us at our booth. Thank you very much.